Today we're going to start chapter 3 about numerical summaries of data, and that chapter starts on page 93. So this is just a continuation of our analysis of data. So we started the last time, the last sessions, trying to get a visual representation of data. So we created graphical summaries of data. The most important ones were the histograms and the bar graphs. They look the same. The only difference is that bar graphs are for categorical data and histograms are for numerical data. So that was our first step in trying to know about the sample and trying to know about the population. Just we were able to know about the shape of the data. So that was our first step. So the shape of the data. Now our second step is going to be getting a numerical representation from the data. We're going to have now numerical summaries of data, which is just numbers. The numbers of the data. So what are those numbers? There are three kinds of numbers that we are interested in. So the first kind of numbers, so let's see, this is going to be the first kind. We are interested in measures of center. So let's see that I'm going to use this figure to indicate that this is a sample or this is a population and this is the visual representation. This is just a general way to indicate a visual representation of my data. So when I'm talking about center, I'm looking for a value that is going to be dividing my data into parts. So that is going to be a measure of center. And there are going to be three different measures of center that we're going to learn today. There are also another kind of measures. They are measures of spread, and they have to do more about the level of concentration of data around a center. So we have maybe data that is spread out in this way, or data that is a lot of concentrated around the center. So we have more spread in this case than in this case. So there are going to be measures of the spread of data, of dispersion of the data. So, and finally, there are going to be measures of position. These are measures that are going to give you proportions. So, for example, if you have your data, you're going to know, given a value, what is the proportion of data on the left and what is the proportion of data on the right of that value. So those are going to be measures of position. So we're going to have one section per one of these different categories of measures that we're going to learn today. So we're going to start with measures of center. Measures of center are covered on section 3.1. So we're going to start today with section 3.1. This section is on page 94 and is measures of center. So that's what we're going to cover now. So measures of center are going to be the most important one is going to be the mean. The mean, we know the mean. We have used the mean a lot of times, and we used to call the mean the average. So we have a notion about the mean already. So the average, but the correct name is the mean, or more specifically, the arithmetic mean. more specifically, the arithmetic mean. So the arithmetic mean is going to be just a simple formula. So we're going to start using formulas from now on, and we're going to use R to work on those formulas. So let's see. On page 95, you have some notation that we need to understand to be able to understand the formulas that we're going to use. So we have a list of numbers. You can see here in your book on page 95, a list of n numbers is denoted by using subscripts. So x1 is one value, x2 is another value from the same sample, up to xn. So this is the notation that we're going to use to understand the different elements or components in a sample. Then we're going to have the sigma. Remember we used sigma the last time. Sigma x represents the sum of these numbers. So sigma x is going to be x1 plus x2 plus x3 up to xn. Then we're going to start with learning about sample means and population means. So the formula is going to be very, very similar. The difference is going to be just the information that we are using. So the sample mean is going to be indicated with X bar. So it's going to be an X with a bar on top of it. And it's going to be obtained by summing, by adding up all the values and dividing that sum by the number of values. The formula is the same for population. What we're going to change is just the symbol that we're going to use to denote the mean of the population. We're going to use a Greek letter, the letter mu, to indicate the mean of the population, and we're going to divide the sum of the values by capital N. So we're going to start talking about differences in notation because in that way we're going to be able to know and learn about the different components from a sample or from a population. So again, we have a population and we can extract, we can collect values from that population and we're going to obtain a sample. So we learned the last time that any value that you use to refer to the population is going to be a parameter. So numerical values describing the population are known as parameters. A single value is just a parameter. A single value, a numerical value that you're going to obtain from the sample is going to be a statistic. So these are the definitions that we learned from chapter 1. So a parameter and a statistic. So in terms of the mean, so the mean of the population, we're going to use the Greek letter mu. The mean of the sample, we're going to use the English letter x with a bar on top of it. So x bar is the mean. Mu is the mean. If you see only mu, you know that they are talking about the population. If you see x bar, you know that they are talking about the sample. So as a general rule, we're going to use Greek letters to identify parameters, and we're going to use English letters to identify any statistic. Remember, statistic is just a number that comes from the sample. So now the formulas for the mean of the population, we're going to need to know the size of the population. So we're going to use capital N. That's the only English letter that we're going to use for a parameter. So capital N is just the size of the population. Lowercase n is going to be the size of the sample. Okay, size of the sample and size of the population. Okay, so with this information, the size of the sample, we're going to be able to compute the mean. So we're going to have a data set. So our data set is going to be consisting of values. So we're going to have values. So it's a data set, and you're going to indicate any value with a variable letter and a subscript, so x1, x2, x3, and so on. And depending of those values are coming from my population, you're gonna use capital N for the total number of values. If these values are coming from the sample, then you're gonna use lowercase n to identify the number of values. So now the formulas that we're gonna use for the mean. So for the population, we're gonna use sum all the x's, all the numerical values, and we're gonna divide by capital N. And for the sample, the same formula, the sum of all the elements in our data set divided by the size of the sample, so lowercase n. So for the purpose of our computations, we're going to use R. So in R, you just need to use a command sum. So for any case, you're just going to have the sum of x. So you need to indicate the values for x, and you're going to divide that by, in this case, capital N, or in this case, you're going to divide that by lowercase n. But in both cases, you need to enumerate, or you need to enter the values. Remember, we enter the values by use a variable and lowercase c to indicate a collection, and then the corresponding values. So we're going to start solving problems. So I'm going to start solving one example to do this work. So let's see. We're going to start with example 3.1. Example 3.1 is on page 94. Page 94. So example 3.1 is the following. Let me show you. So it says that we are given 5 values. So find the mean of the exam scores: 78, 83, 92, 68, and 85. So we're going to compute the mean of this collection. So they don't say whether this is a population or a sample. So we are not going to use a symbol to indicate that. So we're going to just write mean, the mean. So we are given these values. So I'm going to write x equal, and I'm going to say that the values I'm going to enter into R are going to be 78, 83, 92, 68, and 85. Then we only need to add these values and divide by the total number of values. So we need to do only sum of x, and we're going to divide that by 5 because I have 5 values. So this is going to be the mean. I'm going to write just mean. I'm not using x bar, I'm not using mu, because the problem doesn't say whether we are dealing with a population or with a sample. So I think the next step is just entering this information into R. So let's do that. So we're gonna share, let me share now my screen with R. So we have here R. Let me just increase the font size for you to see my work. So we have R now. So I'm going to enter variable X, and I'm going to indicate the collection of 5 values: 78, 83, 92, 68, and 85. So spaces don't matter, but if you want to see a good neat job, just introduce space. So those are the values for x. Then the mean is going to be computed by adding all the values, sum of x, and we're going to divide by 5. So you're going to see that the mean is 81.2. You can also use a formula, a command that is in R. The command is mean, and you just type x, and you're gonna get the same result. But I'm not suggesting to do that because you're gonna have two kinds of data sets. Sometimes it's the data set, or sometimes it's the frequency distribution. And if you use mean with the frequency distribution, you're gonna get a wrong result. So you better use the formula that we are providing. So the formula in this case is just sum of x divided by the number of values. So, and then that is going to be the answer. So that's the first example. Let's see what is the next example that we're going to work on. So we have now the median. So I'm going to first define another measure of center. So the first measure of center that we work on was the mean. So I'm going to write here that this is the number one measure of center, the mean. And now we're going to have the median. That is going to be the second measure of center. Now what is the median? You might find a definition in the book. So let's see, what is the definition? For the median, you just need to check page 96, and they say just a very simple concept. So the basic idea behind the mean is simple. We try to find a number that splits the data set in half. So in other words, we are looking for the value at the middle of the data set. That's what we're looking for. The value at the middle. That's the median. So there is a procedure. The procedure is also on page 96. The procedure is very simple. The first step, you're gonna arrange the data values in increasing order. So arrange the values in increasing order, or decreasing, it doesn't matter as long as the values are in order. Your book says in increasing order. So then you're gonna determine the number of data values. So determine the number of data values. So let's say this lowercase n. Usually this is for sample, not for populations. And then you have two courses of action. If n is odd, then you just look for the middle number. So the middle number is the median. Or if n is even, then compute the median by adding the two middle numbers. And divide the sum by 2. So that is going to be the way. In R, you can use R just to do this sorting. So you can use a function in R to sort your values. So to arrange the values in order, you can have first your data set, again x1, x2, x3, and so on. And then you're gonna use sort x, and that is gonna give you your data set is gonna be now in order. It's gonna be order. So, and again, you just inspect the, the set and look for the value. You can also use a function in R to do that in a single step. So we're gonna work now example 3.2. So example 3.2 is on page 96. So let's see, page 96, example 3.2. Okay, we have here example 3.2. So let me increase the font size for you to see. So example 3.2 is find the median of the exam score 78, 83, 92, 68, and 85. So these are the values that we used before. So let's use R to do it. So first, again, you need to enter the values. So we have X equals C, and again 78, 83, 92, 68, and 85. These are the values. So we're gonna use sort X first, and we have 5 values, n equals 5, so this is an odd number, so you just look for the value at the middle of the set. So let's go and do that with R now. So we enter before 78, 83, 92, 68, 85. So we have X already there, but I need now that data set in order. So I have it now in increasing order. So I'm going to write the results just for our notes, but you can see there that the middle value, the value at the middle of the data set is 83. So, and that is going to be the median, 83. So we're going to write that the median is the value that is at the middle of the data set. So this is the median. So usually in R, on other statistics books, we use X 50 or sometimes X tilde to indicate to denote the median. You can just write the median as in that way. So let's work on one more example. We're going to compute the median again. So and that is going to be example 3.3. Example 3.3 on page 96. So it's on the same page. So we have example 3.3 is here. So now we have a different list of values. So we have one of the goals of medical research is to develop treatments that reduce the time spent in recovery. So 8 patients undergo a new surgical procedure, and the number of days spent in recovery for each is as follows. So we have 8 values. So I'm going to copy those eight values, and then we're going to find the median time spent in recovery. So let's see. So we have the recovery time. Recovery times are, I want to use now Y. You can use a different, or we can use T for time. So let's use T because these are times. So T is going to be 20, 15, 12, 27, 13, 19, 13 and 21. So that's T. Then we're gonna sort these values, and we have n equals 8. Now this is even, so we're gonna look for the values, two values that are in the middle. So we're gonna get the median as the sum of those two values that we're gonna find in the middle, and we're gonna divide the answer by 2. So let's do that in R now. Okay, from the previous problem, we can use also the function median of x, and we're gonna get the same value that we found for the previous problem, 83. Now we're gonna enter times, so t is gonna be the collection of these values: 20, 15, 12, 27, 13, 19, 13 again, and 21. So these are the values. So now we're gonna sort t, and we get our list. So now we look for the two values that are in the middle. You can see that 15 and 19 are at the middle of the list. So we're gonna add those two values, 15 plus 19, and we're gonna divide the result by 2. So we're gonna get that the median is 17. And also we can use median of t, and you also get 17. So, but don't use the functions, use the formulas. Do the procedure, work on the procedure that is given. It's better. You will understand better the concepts if you do it in that way. So that's example 3.3. So now you're gonna have the chance to work on some problems. I'm going to assign in this moment, so I'm just going to give you the third measure of center. So the third measure of center is going to be the mode. The mode, let me see whether the mode is described in your book. So the mode, where is the mode? It's on page 100. So the mode is just the value that appears more frequently. So if you check your book on that page, you're gonna find the definition of a mode. So a mode is just the value that appears most frequently. And you have there example 3.7. I don't think that we don't need to work this on your notes. You just remember the most frequent value is going to be the mode. So 10 students were asked how many siblings they had. The results are arranged in order where. Then you have 0, 1, 2, 3, and 6. So you can use again the sort function in R. And once you get the sort function, you can count the repetitions of everybody. So you're going to find the frequency of everybody. The value with the highest frequency is going to be the most. So in this case, you can see that there are 4 values, 1. So 1 is the most. 1 is the number with the highest frequency. So that's the definition that we needed to complete our measures of center. So again, this is just the most frequent value in the data set, the most frequent value. So you can use sort, and with sort you can visualize better the frequency of every component of the data set. So now you're gonna work section problems on section 3.1. So section 3.1 on page 104. So there is an exercise set there, and I want you to work on 4 problems, and you're gonna send me your answers through the classwork assignment on Canvas. So you're gonna work problems 17, 18, 20, 19, and 20. So 4 problems that you're gonna work. I'm going to project the problems for you, and then we're gonna continue with the second part of our class for this section. So let's see problems. I have with the problems. So 17 through 20. So you have here the problems. So you can see 17, 18, 19, and 20. So it's about finding the mean, the median, and the mode. So we're on these 4 problems, and then we're going to continue with this lecture. I said that the mean is the most important value or the most important measure of center. So now we're going to learn how to compute the mean when we are given a frequency distribution. So this is important. We're going to approximate the mean when you have group data, and that's described on page 101. And this is very important. So you need to understand the difference of doing one procedure or the other. When you have a data set, you can compute the mean just by adding all the values from the data set and divide it by the number of values. Is what we did before a couple of problems ago. So we added all the values and we divided by n, the number of values. So in R, we just did sum of x over n. But when you have a data set, you can also create a frequency distribution, or you might be given the frequency distribution and not the data set. You might not have the data set, only the frequency distribution. When you have the frequency distribution, there is a way for us to compute the mean uh, using the frequency distribution. How are we going to compute the mean? We're gonna need the frequencies and the midpoints. So it's something that we know how to compute, because when we create the histograms, we needed frequencies, we needed midpoints, and we also needed boundaries. But for the purpose of computing the mean, we don't need the boundaries. We only need frequencies and midpoints. So the mean is going to be computed by using this formula. We're going to multiply frequencies and midpoints, and we're going to add all those products. So we're going to sum all the products of frequencies and midpoints, and we're going to divide the result by the sum of the frequencies. So in R, it's just 3 steps. It's going to be very simple. You enter your frequencies, as we did before when we created histograms. You enter the midpoints, and then you apply the formula. This formula that is here now is written here in R by using the R command. So it's the sum, parentheses, you multiply frequencies. We use the star to indicate multiplication. So frequencies times midpoints, and then we divide that by the sum of the frequencies, and that is going to be the mean of the frequency distribution. So we're going to solve a problem to apply this idea that when you have the data that is in a group, then you cannot use the formula, you cannot use this formula for a frequency distribution. So don't add the classes, the classes, or you don't add the midpoints and divide by the number of classes. That's not the process. This is the process you need to follow. You need to find frequencies, midpoints, and then use the formula. So we're going to solve example 3.9. Example 3.9 is on page 102. So it's going to be about computing. We're going to compute the approximate, and this is important. You are not going to get the exact mean from the original data set, because we are using frequency distribution. So the mean is going to be approximated. The approximate mean number of messages sent using table 3.1. So we have here the problem on page 102. So let me show you the problem. First is just what I just wrote. Compute the approximate mean number of messages sent using table 3.1. So we're going to need to copy table 3.1. Table 3.1 is on the previous page. So this is the number of text messages sent by high school students. So we have our classes here. So there are 6 classes, and we have the frequencies. So I'm going to copy this to be able to work on this problem. So let me copy the table. Okay, I have my frequency distribution here, what is given. So I'm going to compute the midpoints. So to compute the midpoints, you just add up two consecutive lower limits from every class. So the first one is 0 plus 50 divided by 2 is going to be 25. Then we can just find the class width. So the class width here is just going to be 50. Is the difference between two consecutive lower limits. So the class width is going to be 50, the class width. So with that, it's very easy to compute the next midpoint because you're going to add 50 to the previous midpoint. So it's going to be 75. Then it's going to be 125. Then 175 plus 50 to 25 plus 50 to 75. So now we have the midpoints. So this is the information that we're gonna need to enter into our console. So we need the frequencies again. So we're gonna write frequencies. It's gonna be a collection of 6 values: 10, 5, 13, 11, 7, and 4. Then we have midpoints are gonna be a collection of these values: 25, 75, 125, 175, 225, and 275. Then we're gonna use our formula. So we have here our formula to compute the mean of this frequency distribution. The formula is just the sum of the product of frequencies and midpoints, and then we're going to divide that by the sum of the frequency. So that's what we need to get the approximate mean for this frequency distribution. So let's do that. Let's go and check in R. So I'm going to enter the frequencies are 10, 5, 13, 11, 7, and 4. The midpoints that we computed are 25, 75, 125, 175, 225, and 275. Check my computation, I can make mistakes. Then I'm going to enter the formula. We're going to sum the product of frequencies and midpoints, and we're going to divide that by the sum of the frequencies. So the answer, let's see, should be, let me check for a moment. So we get 137, so that is the approximate mean. So let's write that down on our notes. So the mean is 137. So now you're gonna work, you're gonna apply the same procedure. So you're gonna work on 4 problems. So this is also on section 3.1 exercise set on page 104. So you're gonna work 4 problems: 21, 22, 23, and 24. So I'm going to give you time to do that, and then we're gonna continue with more on the same. So let's see, we have here those problems. 21, you have a frequency distribution there. You're gonna compute the mean in all those cases. So 21 and 22 are here now. So take a screenshot or pause the video and copy the results. Sorry, copy the frequency distributions. So you have these four frequency distributions. So you have the other two here, 23 and 24. So solve these problems. Find the mean, the approximate mean for these 4 frequency distributions. I'm going to show you the solution of problem 21 just for you to check your work before submitting your work. So problem 21, you have this frequency distribution. So this is what is given. So this is the frequency distribution that was provided. So we have classes from 0 to 9, 10 to 19, 20 to 29, 30 to 39, and 40 to 49, and the frequencies, the ones that are listed here. So first we needed to compute midpoints. So remember, midpoints is just you add these two values and divide by 2. 0 plus 10 is going to be 10 divided by 2 is going to be 5. Then you add these two, 10 plus 20, and divide by 2, you get 15, and so on. But you can also find the class width, which is just the difference between two consecutive lower limits. You can see that the class limit, the class width is 10. So you add 10 to 5, you get 15. You add 10, you get 25, plus 10, 35, plus 10, 45. So once you get the midpoints, if you don't have R, if you only have just a calculator, simple calculator, you need to do these products by using that calculator. So you're going to multiply 13 and 5, and the answer is going to be 65. You multiply 7 and 15, the answer is 105. You multiply 10 and 25, the answer is 250, and so on. So you need to add an extra column for the products of frequencies and midpoints. Then what you need at the end is just the sums. You need the sum of the values in the column frequency, and if you add up these 5 values, you're going to get 50. And then you need the sum of the last column, including the products of frequencies and midpoints. If you add up these 5 values, the sum is going to be 1230. So then you apply the formula. The formula is just a fraction, and the numerator is the sum of the products, and the denominator is going to be the sum of the frequencies. So you divide 1230 over 50, and you're going to get 24.6. You can also use this problem to do it by using R in the same way. So let's do that. That is going to be the last part of our lecture. So we need the frequencies. So I'm going to write now just frequencies using the full word. So you can use any name for the variable. So frequencies are 13, 7, 10, 9, and 11. Those are the frequencies, and the midpoints are 5, 15, 25, 35 and 45. Check my work, I can make mistakes. Then we're gonna get the sum of frequencies multiplying midpoints, and we're gonna divide that by the sum of the frequencies. So, and we should get the same answer, 24.6. So, and that's all for this lecture. So don't forget submitting your classwork on Canvas.